Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Rizky Diandra Oleramineni. You can call me Priska. Today, I will present a tale about passive and active electronic components. This presentation will help us understand the difference between passive and active components, as well as how to read and calculate their value. Learning objective. The learning objective for this material are first, to understand active and passive components. Second, to read resistor and capacitor values. Third, to calculate series and parallel configuration. And lastly, to apply Ohm's law and Kirchhoff's laws in circuit analysis. In this slide, we see the basic difference between the two types of electronic components. One, passive component. Unit require an external power source, the source to operate. Example include resistors, capacitors, and inductors. Meanwhile, active components such as transistors, ICs, and diodes do require external power and are capable of amplifying finance. A resistor is a component used to limit electrical current. Its limit is the ohm. There are several types of resistors such as carbon film, metal ferrite, and variable resistor. Like potentiometer, each type has specific characteristics and applications. Next, color codes. Resistors use color bands to indicate their value. The first then shows the first digit, the second band, the second digit, the third band is a multiplier, and the fourth band indicates tolerance. For example, the color combination brown, black, red, and gold represents 1 kilo ohm with a tolerance of 5%. For resistors in a series circuit, calculating the total value is simple. We just add all the values together. The formula is R total equal R1 plus R2 plus R3 and so on. In a series circuit, the current following through each resistor is the same. Next, parallel resistor. In parallel resistor circuit, the total resistance is calculated using the reciprocal formula. In parallel configuration, the voltage across each branch is the same, while the current divides among the branches. A capacitor is a component used to store electrical charge temporarily. Its unit is the farad. There are two main types: electrolytic capacitors or polar and ceramic capacitors or non-polar. Next, trading capacitor value. For electrolytic capacitors, the value is printed directly on the body, such as 1000 E Fahrenheit 16 volt. Non-polar capacitor usually use a numerical code, for example, 473,000, which means 47 nanofarad. Parallel capacitor circuit. For capacitor in parallel, the total capacitance is calculated by simply adding our capacitance values. C total equals C1 plus C2 plus C3. Parallel capacitor increase the total charge strong capacity. Series capacitor circuit. In a series capacitor configuration, we use the reciprocal formula. Series capacitor carries the total capacitance. And the last, on-flow. On-flow is one of the fundamental principles of circuit analysis. The formula is P equals 1 x L. Using this law, we can determine voltage, current, or resistance in circuits. The current was a presentation on passive and active electronic components. Thank you for attention. If you have any questions, I'm happy to answer. Thank you.